So we're trying to do the 10th structure from the waves worksheet. If you haven't read the question, please go and read. Define for a wave what is meant by displacement. We have already addressed these kind of definitions in the earlier questions. So the B part, use figure 5.1 and 5.2 to determine for the water wave the period, the wavelength and the speed. So for the water wave, the period is the time taken for one cycle here, so that is 0.6 seconds. Yes, 0.60 seconds. Then the wavelength, you have to use this graph, so it's better to start somewhere where we know that the graph is actually cutting the, we are not sure whether this is the peak, right? It might be the peak or it might be a bit less than the peak, we never know. So it's better we start here where we know for a fact that this is the equilibrium point and the wave is there. So one cycle, it goes 5 minus 1, 4 centimeters, 4.0 centimeters. Then once you have V and the period, that means you have the frequency effectively, and the lambda is there, so V is equal to F lambda. So if you look, the marks is given, yeah, so this one gets 1 mark and the final answer 6.7 centimeters per second. Then use figure 5.1 and 5.2 to state and explain whether the wave is losing power as it moves away from the source. Well, this is the source where the distance is the coordinate, the origin. Then as it moves away, it is the amplitude is decreasing, right? The amplitude is decreasing. Here the amplitude is okay, so the amplitude, you can see the amplitude is decreasing compared to here. The amplitude lowers and lowers. So yes, whether it is losing power as it moves away from the source. Yes, because the amplitude is decreasing, so it is losing power. Amplitude is decreasing, so it is losing power. And determine the ratio of the intensity of wave at source and intensity of wave at 6 centimeters from the source. So basically they are expecting you to use this equation where we know that intensity is proportional to the square of the amplitude, which means I at the source and I at 6 centimeters would be equal to amplitude at the source square over amplitude at the 6 centimeters. So they are just asking you to find the ratio. So you just have to now find the values for the amplitude at the source and amplitude at 6 centimeters. Now amplitude at the source, so since they're talking about amplitude at the source, then yes, so this is the peak. Otherwise we can't take it as the amplitude, right? So at the peak it has 2 centimeters amplitude and 6 centimeters from the peak it has, you can see, so each small box, 0 to 1, each small box is, so 1 is divided into 0.2, So here it is 1, 2, 3, 4, 5. 5 means 1, and then half a box, that is mean each small box is 0.2, so half a small box is 0.1, so 1.1. So you have amplitude at the square source 2 centimeters squared over 1.1 squared. You don't have to convert centimeters to meters because it's a ratio, so it's gonna cancel out. So that ends up as 3.3. It's a ratio. Okay, that brings us to the end of discussion in wave structures.